Today we will do the next exercise on the determinants, that is exercise 4.2 of NCERT of class 12th. Now these are called the identities in the determinants, and these has to be solved by using the properties. In these questions we are not supposed to expand the determinant, but we have to solve these determinants on the basis of the properties. For example, I take up the question number 1. Question first of exercise 4.2 is your x plus a, and here the second is y plus b, and z plus c. Now we are supposed to prove it is equal to 0. It is equal to 0 we are supposed to prove. Now what I'll do, I know if two rows or columns of a determinant are identical, the determinant reduces to 0, can be written equal to 0. Now clearly what I observe, x plus a, y plus b, z plus c, it is column C3. And if I operate C1 plus C2, here I am going to operate C1 to be written as C1 plus C2. So what does I get? I get it x plus a, y plus b, and z plus c. Second column as it is a, b, c. Third column we have been given already x plus a, y plus b, and z plus c. Now if we observe here, our C1 and C3 are identical. So when two columns are identical, so that determinant must be equal to 0. So what is the reason for this one? Because C1 and C3 are identical. Or this is one of the property that whenever two columns or rows are identical, the determinant reduces to 0. Hence, it is being proved. The question number first is done. Now let us go to the question number second. In the question number second, what we have? Let us go to the question number 2 of this one, determinants. In that question, we have first row a minus b, b minus c, c minus a. Question 2, determinant a minus b, b minus c, and c minus a. The second row is starting from b, b minus c, and your c minus a minus b. On third row is the third row we have with us c minus a minus b, c minus a minus b, and b minus c. It is to be proved to be equal to 0. It is supposed to be proved equal to 0. One of the property we have done, that if one of the column or one of the row completely is equal to 0, contains all the zeros, so then that determinant also reduces to 0. Now what I observe, if I add up these two, if I operate like this way, C1 to be written as C1, C2 and C3, what we have, a minus b plus b minus c, a minus b plus b minus c plus c minus a. Similarly, b minus c plus c minus a plus a minus b. Similarly, c minus a plus a minus b plus b minus c. And second column as it is c minus a and a minus b. Third column to be written as it is c minus a minus b, and b minus c. So now what do we observe right here? That is A minus B, C, A. So similarly, what we get here, that is the first column, get all the elements in the first column gets cancelled and the first column C1 becomes 0. So that means further determinant becomes, what it becomes? 0, 0, 0. And then as it is B minus C and C minus A, or C minus A minus B, and here B minus C. Now C1 is completely 0. Yani all the elements of the C1 is 0. So that means our whole of the determinant is equal to 0. So hence it is proved. Whatever supposed to prove, we are able to prove. Yani first of all, this was a given determinant. Question number 2, it is question number 2, determinant is given. I operated C1 to be written as C1 plus C2 plus C3. After adding all these 3 columns, we get the first column to be 0, 0, 0, and that means whole of the determinant is equal to 0. Now let us go to the next important question, question number 4 of exercise 4.2. Question number 4. What does it gives us? Question number 4 gives us the first column is 1, 1, 1, 1, 1, 1. Second column is your B, C, CA, CA and AB. Third column, if we clear the brackets right here, we get in third column AB plus AC, AB plus AC, and the next one BC plus BA, and CA, CB, CB. ऊपर मेरी वो बंद कर दो सिंटेक्स. CA plus CB. Now after doing so, what I look at it how to get the, how to operate it, so simplify it so that I get some of the property can be used here. Then if I do the analysis of this determinant and look at very carefully, what I observe, if I add up C3 and C2, I will be getting AB, BC, CA, AB, BC, CA, AB, BC, CA. So this all will become same. Third C3 can be made same. How? C3 can be written as C3 plus C2. So what we hear, 1, 1, 1, it is BC, CA, AB. Adding all this, we get AB, BC, CA, AB, BC and CA, AB, BC and CA. Now this, all the elements of the C3 are same. It can be taken out common. So after taking out common, what we have, if I take out the common AB, BC, CA, I will be left with 1, 1, 1, BC, CA, AB, and in the third column again 1, 1, 1. Now C1 and C3 are identical. So that means determinant reduces to 0. So what can be written as C1 and C3 are identical. Identical. So that means this determinant is equal to 0. It can be written as equal to 0. So hence it is also being proved. Now let us come to the next important question, say question number 7. Now I just reached the question number 7 of exercise 4.2. So what does the question number 7 says of exercise 4.2? There we have minus a square ABAC. Question number 7, we have, that is your minus a square AB AC, and the second row we have is BA minus B square BC, BA minus B square BC, CA CB minus C square, and it is supposed to prove equal to 4A square B square C square. So this is what I am supposed to prove. Again, check the question after writing in the exams. Always check the question. Sometimes, in case you do the mistake in writing the question, so then we can get the answer to be correct. So now minus a square ABAC, BA minus B square BC, CA CB minus C square is equal to 4A square BC square. Now after writing so, what I do, first of all, what I look at, I see A and B and C are common in all the rows R1, R2, R3. So what should I write down? Taking A, B, C common from R1, R2, R3 respectively. So then we will be having A, B, C common. Already left minus A, B, C. B has been taken from the second row. A minus B and C. C has been taken out common. C from R3. So we will be left A, B minus C. Here we are left here. If we are taking A, B, C common from R1, R2 and R3. Now, again I look at the what determinant left behind. A is common in C1, B, C2, C, C3. So next we do take out common, taking common A, B, C from C1, C2 and C3. If we take out a common A, B, C from C1, C2, C3, so here we'll get A square, B square, C square minus 1, 1, B common, 1, 1 minus 1, 1, 1 minus 1. So this is being left behind after taking out ABC common again from the second time. Now, after doing so, what I observe, if I operate R1 plus R2, R1 plus R2 and R2 plus R3, so next step I am going to do, what I am going to do, I am going to operate R1, I am R1 to be written as R1 plus R2, R1 plus R2 and R2 to be written as R2 plus R3. So we will be having A square, B square, C square common as it is, minus 1, 1, 0, 1 minus 1, 0, 1 plus 1, 2, and R2 1 plus 1, 2, minus 1, 1, 0, 0, and 1, 1 minus 1. So this is being left with us. Now, what I do the next, I will expand this determinant from the row or column in which the maximum number of zeros are there. If I observe it, maximum number of zeros are in R1 or R2. There is 2 zeros in the R1, 2 zeros in the R2. So it will be better I just expand it from R1, and we can expand it to R2 also, the same thing. Okay. Now, what is your, here we are left with your A square, B square, C square. For 0, 0. It will attain the sign plus, minus, plus. That means 2. I expanding through R1, and both the first 2 zeros makes the whole element 0. The third 2, I write it down outside, just how to expand the determinant we have done in the previous lecture. I hide this one and this one. I hide R1 and C3 because 2 lies in R1 and C3. After hiding these, what will we have? 2 ones are 2 minus 0. 2 minus 0. This is the way. 2 twos are 4. So answer comes to be 4 A square, B square, C square. And this is what you have to prove it. So we can write down this whole is equal to 4 A square, B square, C square, and hence proved. So this is a way that we are able to question 7 of exercise 4.2. That is, again we are supposed to prove, हमने क्या prove करना था? This determinant is equal to 4 A square, B square, C square. And first of all, I took out the common A from R1, B from R2, C from R3. Okay, A, B, C comes out. Then this is the determinant left behind. I take out the common A, B and C respectively from the columns C1, C2, C3, and we get A square, B square, C square. And after this one we are left with minus 1, 1, 1, so and so. Then I operate R1 to be written as R1 plus R2 and R2, 2 plus R3. So while adding R1, R2, 0, 0, 2, 2, 0, 0 and R3 as it is 1, 1 minus 1. On expansion of this determinant, we get 4, and 4 A square, B square, C square already is common from this determinant, and overall we get the 4 A square, B square, C square, hence proved, and hence it is proved. Thank you for watching. The next we come to the important question. That is question number 11 of exercise 4.2 of our NCERT. Now again we have got one of the identity, that is your A minus B minus C 2A so and so supposed to prove equal to A plus B plus C ka whole cube. Now clearly we want, this has to be reduced into A plus B plus C, and 3 times this factor must be there so that we get the A plus B plus C ka whole cube on simplifying this determinant. So clearly we want A plus B plus C. So what I observe, if we add up R1, R2, R3. So what else do we do? R1 to be written as R1 plus R2 plus R3. So this statement means in the row first, add up the row second and row third. Now A minus B minus C, when we add up 2B and 2C, so we will be left with A plus B plus C. Similarly, 2A plus all this, 2B minus C, 2A minus A, 2C, we get A plus B plus C. 2A, 2B, so and so, we get A plus B plus C. And the second rows as it is. Third row again as it is. C minus A minus B. A plus B plus C we can take out common. If I take out the common A plus B plus C out of this one, So after taking out the common, we will be left with, I am taking out the a plus b plus c common. Now, what will be left with? 1, 1, 1. First row is 1, 1, 1. And our second row is 2b, b minus c minus a, 2b, and 2c, c minus a minus b. Now this is what you get. Remember, what is the concept of solving the determinants? We should always try to get the maximum zeros. What I am saying, first row containing 1, 1, 1. I will try to get the maximum zeros in any of the row or column. It is quite easy to get the maximum zeros in the R1. If I subtract, what I do? C2 minus C1. C2 minus C1, that means we will get a 0 here. Again, if I do C3 minus C1, I will get a 0 there. So how I am choosing like this way? Because C2 has b minus 3 terms element, and it should be subtracted from this one. It is the simplest one, 2b, 2c. Similarly, C3, c minus a, this element, this element. So when subtracted, this subtracted from this one, this subtracted from this one, so we'll get the simpler terms. Apart from that, we'll get the 0, 0 here, and then it can be expanded, and we are supposed to get a plus b plus c cup whole cube. Now listen to how I do it. So first of all, after doing this one, the next step I operate, that is C2 to be written as C2 minus C1, and C3 to be written as C3 minus C1. A plus B plus C common as it is. C2 minus C1. C1 as it is. 1 minus 1, 0. B minus C minus A minus 2B. Minus 2B. That will give us minus A plus B plus C. 2C, 2C, 0. Similarly, 1 minus 1, 0. 2B minus 2B. 1 minus 1, 0. 2B, 2B, we get 0. And C minus A minus B minus 2C, we will be having minus common A plus B plus C. Now, we want 3 times A plus B plus C. We have obtained. How? C2 contains A plus B plus C, and C3 contains A plus B plus C. Just look at this one. This is C2, and this is our C3. In both of these, C2 and C3, this is our C2 and this is our C3. So taking out common A plus B plus C, A plus B plus C from C2 and C3, it becomes A plus B plus C whole cube, and that is what I am supposed to prove. So now the next step is your taking out the common A plus B plus C from C2 and C3. So we will be having A plus B plus C whole cube, and determine left 0, 1, 2B, 2C, 1, 2B, 2C, 0, minus 1, 0, 0, minus 1, 0, 0, 0, minus 1, 0, 0, minus 1. Now, this result is sufficient. If it becomes 1, this whole determinant becomes 1, so then our answer is correct. That is A plus B plus C ka whole cube. This is what is being required on the right hand side. So now, just expand it. Again, before expansion, we should look at the row or column which contains the maximum zeros. R1 contains 2 zeros, C3 contains 2 zeros. We can expand it through R1 or C3. So we have got the preference, options, two options, either R1 or C3. The rows are better to expand. From our practical experiences, it is always there, the rows are easier and better to expand. So I will expand through R1. If I expand it through R1, so what I am going to have, A plus B plus C whole cube, A plus B plus C whole cube, and right from here 1, hide this one, minus 1, 1 minus 0. So we obtain here, that is 1 minus 0. What I was doing while expansion, the first A11 first element, hide the first row and the first column, it is in the first row and first column, and after hiding these one, what we have, this to multiply this one minus this one. So that is minus 1 into minus 1 plus 1 minus 0. So answer is your A plus B plus C and whole cube. And this is what to prove on the, this is right hand side, hence proved. So this is right hand side and hence our answer is correct. So this is how we can expand the determinants. Now let us go to the next important question. The next important topic, you can say, how to find the area of a triangle with the help of a determinant. Whenever earlier classes you must have learned there are two formulas for finding the area of a triangle. That is your Heron formula, S into S minus A, S minus B and S minus C under root. This is how to find the area of a triangle, where S is semi-perimeter of the triangle. And in case we have got a triangle, that is A, B, C are the sides, A, B, C are the sides, then we can apply this formula to find the area of the triangle. The next, you have done it, how to find the area of a triangle is equal to half base or any side of a triangle corresponding altitude, half base into height you generally say. So now this is a, for example, this is a triangle and we have got, this is a right angle. So this is our base and this is height, altitude, half base into altitude. These are two formulae quite popular. Now the next we are going to get here, in case the vertices are given, A, B, C, three vertices are given of a triangle and we are supposed to find the area of a triangle. So with the help of determinants, we can find that. So now let us go to the formula for finding the area of a triangle with the help of the vertices of the triangle. So that comes to exercise 4.3. The next topic is finding the area of a triangle or with the help of the vertices. Now, what is the formula for that? Area of a triangle, that is half 1, 1, 1, x1, x2, x3, y1, y2, y3. What are x1, y1, etc.? There, this is a triangle we have, and the vertices we have, that is your x1, y1, x2, y2 and x3, y3. Suppose these are the vertices being given to us. So then we are, ABC is a triangle, any triangle maybe secline, isosceles, equilateral, or whatever kind of the triangle it might be, or maybe right angle triangle. In case we have been given the three vertices, we can find the area of the triangle with the help of this determinant, this formula. You can say that is 1, 1, 1, x1, x2, x3, y1, y2, y3. Now we go for the question number first of this exercise. The first is there. Find the area of the triangle. Find the area of the triangle. Question first, part second. Vertices are given 2, 7. We have been given the vertices are 2, 7. 2, 7. And second vertex 1, 1. 1, 1. And third one is 10, 18. 10, 8. Sorry. Now, what is the area of the triangle? Half 1, 1, 1. x1, x2, x3. 2, 1, 10. 7, 1, 8. 7, 1, 8. So this is what we have. Now we want to find the area of this triangle. We can expand it straight away, or if we want to make it simplify using the properties, we can do that. C2 minus C1, C2 minus C3. So we can C2 to be written as C2 minus C1, C3 to be written as C3 minus C1. So then it becomes half 1, 2, 7. 1 minus 1, 0. 1 minus 2, minus 1. 1 minus 7, minus 6. 1 minus 1, again 0. 10 minus 2, 8. 8 minus 7, 1. So this is the determinant on simplification. Again, to expand it, we are going to just try to see where the maximum zeros are there, in which row or which column. I observe that is the maximum zeros are present in the first row. So expanding through the first row, half. So that is 1, hiding this one, 1, this one minus 1, 1, we get minus 1, minus 48, minus 48, minus this way, minus 48 plus 48. So overall we get 48 minus 1, 47, and area of this triangle comes to be 47 by 2, and these are always square units because areas are in the square units. So in this way we can find the area of a triangle. Now suppose we have been given the 2 points. We are being given 2 points on a line. We are given the 2 points on a line and we want the equation of the line. How can we find out with the help of the determinants? It is the question number 4 of exercise 4.3. Let us go to question number 4 of exercise 4.3. We have been given one of the lines, straight line, and on the straight line we have been given the 2 points. Question 4. Find the equation of line 2 points 1, 2 and 3, 6. And using determinants we are supposed to find the equation of the line. We know in case that it is a line, instead of this triangle, if I bring this A on the BC, it becomes a straight line. A comes here and this is B and this is C. Now what is the area of this triangle ABC? When A, B, C are collinear and it is straight line, then the area is 0. The area of the triangle would be 0. So this concept we will be using. That means when the line is there and one on the point I take up as XY. I am taking the point A, XY. and your B is given to be 1, 2 and C is given to be 3, 6. Now the 3 points 1, 2, x, y, 3, 6. One of the point we have to take a general point x and y on the what is called coordinate axis. So now this area of triangle half 1, 1, 1, 1, 1, 1 or the x1, y1, this we have 1, x, 3, 1, x and 3 and then come the terms y1, y2, y3. y1 is, this is her 2 and it is y and 6. This whole is equal to 0 because these 3 points are collinear 1, 2, x, y, 3, 6. So here x1, x2, x3, 1, x3, 1, x3, y1, y2, y3, y1, y2, y3. Now simplify it and get the triangles, area of the triangle. So we straightway expand it through the R1. I hide this one, first row, first column, just multiply this one, 1, 6x minus 3y, 6x minus 3y. Then the second one, now I am coming here, hiding this one, I get 1, 6 are 6 minus 6. And after this, I come to this one, hiding this column and this rows. So what we obtain, this column and the first row for this one, plus 1, y minus 2x, y minus 2x. If I hide this, then R1, C3 and we multiply y minus 2x. So now this is the what is called equation of the triangle and this whole is equal to 0. Now let us simplify half 6x minus 3y whole becomes 0 plus y minus 2x equal to 0. This half comes to this side becomes 0. Now we are getting here 6x minus 2x 4x minus 3y y minus 2y equal to 0. Again 2 is common. Let us check it out. That is your 2x minus y is equal to 0. So this is the equation of a line on which 1, 2, 3, 6, 2 points are to be given. Or it may be written as like this way, that is y is equal to 2x. So both the answers are correct. You may write down this way or this way. So this is how to find the equation with the help of determinants and area of the triangle with the help of the determinants. I hope. So next time we'll just start in the next lecture we'll start the next one, how to solve the linear equations in the 3 variables. Okay, thanks for watching.